Okay, hi everybody. So what's a power series centered at C? Okay, so there's some complex number C, which is an element of the complex numbers. Anyway, I'll just call it like that. Well, turns out there's a little circle, or a circle with a radius, where everywhere in here, the power series centered at C will converge. It's the radius of convergence of a power series. What is that? I mean, what's the power series? It's like x minus c to the n, where n is going to go from 0 to 1 to 2 to 3 to 4 all the way forever, and it's going to have some coefficients. Okay, and if we're thinking about this as a complex function, it takes the complex number x and sends it to this. So it's a map from the complex numbers to, well, this would be a complex number if it converges. Okay, and we get to choose these coefficients, right? And we get to choose like where are we centered at. So in particular, like if we just do x minus 0 to the n, well, that just looks like x to the n. And this is a power series centered at 0, which has some radius of convergence or whatever. But we can shift it around. We can move it around and center it at other places. Wow. Okay, so let me answer the question. What's a power series centered at C? Anything of the form infinite series. Let's say n equals, well, it has to start at actually 0 to be, well, yeah, anyway, where you have some numbers, maybe these are complex numbers, maybe they're real numbers, times what? Powers of x to the n, or sorry, just x to the n, that's powers of x. And we're going to allow a little sort of shift, okay? And that's a power series. Oops, there we go. So in particular, zeta of 2 is the infinite sum 1 over n squared, n equals 1 to infinity. This is not a power series. Okay. Here's another interesting function. Let's say 1 over 2x plus 5 plus 3x plus 4x squared plus x to the third plus x to the fourth over 4 factorial plus da 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 da. And this part right here makes it not a power series. This has a exponent of x to the negative 1, which makes it a Laurent series or something like that. And that's not a power series. Okay. Wonderful. A. What is a power series? Anything of the form like that. B. What is a radius of convergence? It turns out that every power series has a small or possibly large, okay, so then why am I even saying small or large? Has a disk centered at the point that this power series is centered at C. Every power series, like above, has a disk centered at C. Inside, maybe, and I'll say, and inside that disk, the series converges. In other words, if you plug in x to be any number that's inside that certain disk around the point C of some radius, usually that's called capital R, the radius of this radius of convergence, then it'll converge. Okay, so it turns out that every power series has a disk centered at that point. So if this was, 0, then it'd be a disk centered at 0. And inside that disk, the series converges. Done. That's the radius of convergence. See, briefly explain the proof that the radius convergence exists. Don't prove it in detail, just give the idea. So, the ratio test. The ratio test, in particular, the proof of it, shows, what does it show? Shows that if the, okay, so what are these? Here they are. Shows that if the absolute value of n plus 1 divided by the absolute value of the nth term shows that if this sequence, this is a sequence, let's call it, I don't know, b sub n, or maybe we should have called it r sub n for ratio. If it converges, so this arrow means converges, a sequence converges, sequence convergence, to L, which is less than 1, then the series will converge. And now let's look at this thing. Let's look at this. It says a n plus 1 over a n. And then look at these pieces. There's n plus 1 of them divided by n. We're just going to get an x minus c. And if this is some, in particular, if this goes to L, let's just say that these ones go to L. Just to make it less than 1, I don't know, the limit of this thing should be some number L. Yeah, let's say that these approach some limit, some limiting value. Then the ratio test says that if that limiting value is less than 1, well, that just means that now we have a condition on how far can x be away from c? Well, 1 over L. You see that? If this thing is less than 1, then the series that has, the series that has these terms will converge, right? If this thing is less than 1, this series will converge. That's just a ratio test. But this thing will be less than 1 exactly when, if I divide by L, x is really close to c. And so whatever this number is, this is the radius. This is the radius. And whenever x is really close to c, in other words, x is in here. Okay? And for a power series, you see this is always going to happen because the power series always has this thing. And it's always going to cancel every time like that, leaving just one of these with the absolute value, which is the radius of a disk. It's a disk centered at C. Okay, so let me try to do this better. That was terrible. The ratio test, the proof of it, shows that if the sequence of ratios limits to L less than 1, the series will converge. Okay, my pencil stopped working. But the ratio test shows that if the sequence of ratios limits to some number less than 1, then the series will converge. But for a power series, this number will cancel with the one below it and give us just an x minus c absolute value. But, for power series, x minus c absolute value always hangs out. Always hangs out. And so if we can just make this small, if this is small enough, then it'll be less than 1. So we get, that 1 over L, whenever x minus c is less than 1 over L, we get convergence. Convergence. For all x such that this thing is less than that, we'll get convergence. Okay, that's the idea. For power series, this will always hang out in that consecutive ratio thing that we do. Because it'll have an n plus 1 and an n, and then those will cancel, and we'll just get that. Maybe you can explain it better than me, briefly.